Hello students and welcome back to Mechanical Engineering Practice and Graphics. I hope you have had a relaxing spring break last week. For this week, we're going to be covering chapter 8 of the book. It's called Advanced Modeling Tools, the second part. Last week before the break, I did a couple of tutorials on different complicated parts. Please review that and also review how I'm gonna solve the last homework on this class, and also I'm gonna do an additional tutorial. Um, for this week, we are in week number 9. We only have the homework number 6, and also you have to be working on your final project. So each one of you will be submitting the first part of the final project. Each one of you is gonna submit a different part within your groups, of course. Um, Remember that each member in the group must submit at least 5 different parts, and that all the different parts within a group must be different. Um, Also, I shared earlier today this spreadsheet that I did with information that you provided. So in this spreadsheet, you will find your names, your ABC123, and also the group number that I assigned for all of the groups. Also, some students didn't share any contact information for the groups, so I just decided uh, who is going to be working with who for those students that didn't do uh, this task. So please review this. If you want to suggest any modification, just let me know. I will modify the file and submit it again to Blackboard. So for this week, we don't have any quiz, any midterm exam. We just have one homework, and you gotta be starting with the final project. However, next week we will have the third quiz. Probably I'm gonna do it on Thursday. So heads up to the GroupMe chat. Um, and as usual, the file will be available for you at first hour of the day, and you will have until the midnight of the same day. All right, so for this week, I'm gonna start by showing you how to do the last homework, and also I'm gonna do an additional tutorial, but first I'm gonna start with the homework. Okay, so I'm gonna open SolidWorks, create a new part, and here I'm gonna use the top view, which is the view that has most of the information for this geometry. So starting from the top plane, I'm gonna create a new sketch. And as usual, I'm gonna define a few lines for construction in the origin of the plane. But also, I'm gonna define this position for this arc here, the center position for this arc, the center position of these couple of circles, and also this end on the left of the part. So one line here, another line here, and another line here. From the blueprint, we know that this center, so the origin in my sketch is gonna be in this intersection between this vertical line and the horizontal line here. So from there we know this 100 distance and also this 125. So I'm gonna go ahead and define those dimensions. Again, using the Smart Dimension tool. Also, from the front view, or which in this case would be like a side view, we have the distance between the center of these circles and the left end of the part, which is 180 millimeters. All right, now I'm gonna draw. First, I'm gonna start with these two circles here with diameters of 22 and 32 millimeters. Those are here. The first one is 22 and the second one is gonna be 32 millimeters. Next, I'm gonna do this circle here. So this is an arc, but I can draw the entire circle, and the same goes for the one on the right. So the one on the left, I don't have either the radius or the diameter. I'm gonna do that by construction, and I'm gonna show you how. But the one on the right, we have the radius that is equal to 6. So this one has a diameter of 12 because the radius is 6, as we have here in this dimension. Then we have a line that should be tangent to this circle and should go all the way to this other circle. Now, I'm gonna define that this line and this circle are tangent, so I'm gonna add a relation there between the line and the circle, and also for the couple on the left. And we have one additional information here, which is this slope of, or the angle between the horizontal line and these lines here, which is 3 degrees. So I'm gonna go ahead and define that angle there by using the Smart Dimension tool. I'm gonna start clicking any of the two lines and then the other one, and then I can define the angle here, 3 degrees. As you see, this line has this slope, and also we know here that it's tangent to the circle and that this point is coincident to the circle. That means that the line is actually touching the circle, and the same for the other one on the left. Next, what I'm gonna do is I'm gonna draw just another line here with whatever slope, and then I'm gonna add a relation there that this line and this other line both are parallel, which means both have the same slope of 3 degrees, which is what we see here in the blueprint. Now, the distance between the inner edge and the outer edge is only 5 millimeters. So I can define that with the Smart Dimension tool, 5 millimeters. And then here on the right, we have another arc. As you see here, we have this arc with radius 20, which is exactly the same in the other side. So I'm gonna go here to the arcs, and I'm gonna select the second option, that is tangent arc. I'm gonna click in this point here and then on the circle. Of course, this line or this arc is not tangent to this circle, so I'm gonna add that relation there to make a smooth transition between those two. And then I'm gonna define the radius of that arc, which is 20 millimeters. like that. As you see, this is black. Everything is black there, which means everything is fully defined. Um, Even when I have this under defined here, I know that is this point. I can move this point around. Now, what I'm gonna do next, I'm gonna use again the tangent arc, this time here on the left. I'm gonna create an arc that is tangent here to this line. Now this arc here, we have that has a radius equal to 50 millimeters. We can go ahead and define that radius, 50 millimeters. And look that if I try to move this point around, I can modify all the geometry. That's why we have these 3 degrees. So what I'm gonna do is I'm gonna draw a line from this center of the arc. So the arc has a center because it's basically a circle or a portion of a circle. So from the center, I'm gonna draw a line. Actually, I'm gonna click here in that it's infinite and that is for construction. Starting from that center, and then this line is diagonal. It has a certain slope. From the blueprint, we know that the angle between the vertical line and that diagonal line is only 3 degrees. So I can define that by clicking any of the two lines and then the vertical line, then here and defining the angle, 3 degrees. Now as you see, if I move this line around, I will modify the position of the arc. Also, the additional information that we have is that the arc is the position of the arc where so if I move the line around, I can modify the position of the arc. So the additional information that we have is that the point at which the arc stops being an arc and then it begins being a straight line is coincident to that vertical line. That's why we have the construction line only to until that point. That means that this point here and this line here are actually coincident, and then we can define that relation between those two. That is how we define the center position of this arc. However, we haven't defined the end of the arc yet. So for doing that, what I'm gonna do next is I'm gonna start by doing the two arcs that are here on the left. I refer to these two arcs, the one with radius equal to 25 and the other one with radius equal to 31. And for those, I'm gonna use the center point arc, the first option in the arcs. This is the first one, and then we have a second one. So the inner one has a radius of 25, and the outer one has a radius of 31. From here, I'm gonna show you that the center of these circular holes that we have in the section AA, as you see here, we have a section view that is presented here on the right. And we have two circular holes that are going through these points here and here. So I know the position with respect to the center of, the part, which would be this line here. And I'm gonna draw this line here that is the center of those cylinders. basically. So I'm gonna draw a horizontal line that is infinite and for construction somewhere here. And then we know this distance from one center of one of the circles to the other one. Now they should be symmetric, which means we have half of this 74 millimeters on the top and the other half on the bottom. With that in mind, I'm gonna define this distance here as 74 divided by 2, which is 37. And then I can draw these lines here. So the other information that we have is that the edge of the material in this section, we know that it's like a circle there, or half a circle, has a radius of 7.5 millimeters. So I can define that distance here between this center and this edge is 7.5 millimeters. And then we have um, this distance here, which is 22. As you can verify here in the blueprint, it's 22. And then I can finish by having a fillet here in this um, corner, which has a radius of 5 millimeters. So I'm gonna change the radius to 5, and then I'm gonna select the corner, and then click OK, and that's it. So I have now all the geometry in the top. I can now mirror what I need at the other side. So I'm gonna start with this line and continue from there all the way here, and also I'm gonna include this one. And then the mirror that I'm gonna use is this center line here. And that will do the trick. So I have now all the geometry there. I can exit this sketch now. And then I'm gonna go to extrusion. And here I'm gonna select the contour, this contour. For this one, I'm gonna select the mid-plane option. And finally the distance, which is only 15 millimeters. I'm gonna change this one here for 15. And then I'm gonna click OK. Then using the same sketch, I'm gonna create a second extrusion. This time I'm gonna do it for this cylinder. Again, I'm gonna use the mid-plane option. And this time is 22 millimeters, the distance that I need to extrude, that it's right here. So here I'm gonna define 22 millimeters, click OK. And the last one is gonna be here, this um, cylindrical shape that we have on this edge with a extrusion of 35 millimeters. So again, using the same sketch, I'm gonna click in extrusion, then I'm gonna select here 35 millimeters and using mid-plane option, and then OK. Then I'm gonna do using the fillet option. I'm gonna click here in fillet, the first option, and then I'm gonna go in the fillet type. I'm gonna select the third one, sorry, the fourth one, the last one, which is the full round fillet. And then I'm gonna select for the first face, I'm gonna select this face. Then for the second face, I'm gonna select this face. And for the third one, the opposite side. And as you see, it will create a full fillet using those three faces. And I'm gonna do the same at the other side. I can just mirror this operation, or I can just create another fillet. So either way is equivalent. I am missing the two circular holes here, so I'm gonna create a new sketch there. And press Ctrl 8 in my keyboard. As usual, I'm gonna start by having these lines for construction here and here. Then I'm gonna draw a circle here. It is showing me the center of that arc, so I can take advantage of that. I know that the distance using this as a mirror is gonna be 74, but it already recognized that because I'm using the center of this arc. So instead of doing the circle there, I'm just gonna do the circle somewhere else and define that dimension just to make sure. And then those two circles have a diameter of 10 millimeters. And then I can use the mirror entities to copy this circle at the other side. Then I click exit sketch. And for this one, I'm gonna create an extrusion of a cut. And in the option, I'm gonna define up to next and then click OK. So we have those two circular holes there. We're almost done. We're missing the last piece, which is, as you see here, we have these fillets here in the top and also in the bottom, as we see with these lines for construction here in the front. And also we have the same fillets on these circles in the top and in the bottom. To define those chamfers, actually they're not fillets, they're chamfers. I go to the fillet, in the deployable I select the chamfer option. Here we have that they have a depth of 1.5 millimeters at 45 degrees. That's what these two parameters mean. And then I just have to select all the edges where I'm gonna use this kind of chamfer. At both sides. As you see here is uh, the same parameters for the one here and the one here. That's why I'm doing everything in one single step. And that's it. That's our final part. So this is how you do the last homework. Um, some of you had a couple of mistakes, nothing too bad, but now you understand how to do it. Okay, and now for the second tutorial, I'm gonna do this part. Let's begin. I'm gonna start a new part. And here I'm gonna start with the base of this part, which is like this rectangular shape here with the circular hole. So I'm gonna start by using the right view, creating a new sketch, as usual, my lines for construction. Okay. Then I'm gonna keep the origin in the like in this position here and in this position here. which means I'm gonna draw just a rectangle from here to here. Then I have 45 millimeters in the height, and I have 69 in the width. Then we have a circle somewhere with that size of 16 millimeters in the diameter, and then 22 in the horizontal, this in the horizontal direction, and 18 in the vertical direction. Like that. Next, I'm gonna exit this sketch. I'm gonna create an extrusion of 10 millimeters. I know that it's 10 millimeters from this dimension here. So 10 millimeters in the X direction. And then using this face here, I'm gonna create a new sketch. Control 8 and Control 8 again. Now I'm gonna draw this part here. So I'm gonna start from here in the origin to the right, then to the bottom, right, up, left and down. Okay, from here we know that this thickness is 10 and remains constant in all the geometry. So we have to define that thickness here and also here. Okay. Then we know that the distance from this base of the geometry and the top of this L shape, it's 85 millimeters. So I'm gonna define that distance here, 85. And also we know that the distance from this end here and the top edge of this rectangular shape is 75 millimeters. So I'm gonna define that distance like that. Next, we have a couple of arcs here, one with radius 5 and the other one with radius 15. So we can click here in the sketch fillet. The first one is 5 millimeters, and it's this one that we have here. And the next one is in the other corner with radius 15, which is here. I can exit this sketch now, everything is defined. So exit, and then I'm gonna create an extrusion. Now this extrusion should go actually inwards, so I'm gonna reverse the direction, and the distance for that extrusion is equal to the diameter of the circle here, which is 38. So I have 38 millimeters here. And then, okay. Now, from this shape, I'm gonna create an auxiliary plane. Using as first reference this face here. The plane is gonna be parallel to that face, but in the other direction. And the distance is gonna be these 14 millimeters that we have here. That's why I have this 14. Now, using that plane, I'm gonna create a new sketch. Control 8 again. Since I don't want to do this curve again, I'm just gonna use the convert entities tool to define that line over there, and then I'm gonna create something like this. Okay, then we have, again, the thickness is 10 millimeters, which should be constant all the way. So 10 millimeters here and 10 millimeters here. And then we have a fillet here of radius 25. And that's it. I can exit this sketch now, create an extrusion to the other direction, and this extrusion is gonna be also 10 millimeters. So here I have to change this one for 10, and then I can click OK. It is taking shape now. Now I'm gonna use this plane to create a new sketch. Control 8. Here I'm gonna do this circle here of diameter 38. So here I'm gonna use the second option in the circles, which is the perimeter circle. I'm gonna use this corner, this other corner, and any other point. And I know that I'm gonna add this relation here between this center and this line here. They both should be coincident. And that will define the position and the size of this circle. So I can exit this sketch now. I'm gonna hide this plane by clicking here in hide and show and then the view planes. Okay, then I'm gonna use this sketch to create an extrusion. In this direction, we know from this view that is 12 millimeters. But then we know that it also has a second direction towards the other side. The total should be 25, so 25 minus 12 is going to be 13. And that's that shape that we have there. Next, I'm going to do this fillet here and this fillet here. The first one has a radius of 31. So here I'm going to use the first option using 31 millimeters and using this edge here. Okay. And the second one has radius of 20 millimeters. This one is 20 millimeters and it's this edge. Okay, we're almost done. Now I need to draw these holes in this face. So using this face, I'm gonna create a new sketch. And then I'm gonna use the center circle. Actually, I'm gonna use the convert entities tool first to define this circle, but then this circle is gonna be only for construction. I just want the center of that circle. And from that center, I'm gonna draw the other circles there. Now, this one is gonna be also for construction. And then I'm gonna draw a circle somewhere that has that the center of this circle must be aligned or coincident to this circle for construction here. Now, this hole has a diameter of 16 millimeters, this one. And then the circle for construction has a diameter of 25. And then this one, there are 6 of those with diameter of 4 millimeters. And now I'm gonna draw a horizontal line for construction that it's infinite here. And then another one that it's as a sketch from here to here. So this line goes through the 2 centers, the center of this small circle and the center of all of these 3 circles. And that's because I need to define this angle here, which is 45 degrees. And then I can click here in linear sketch pattern. The second option is the circular sketch pattern. So here I'm gonna select this center. And the entities is gonna be this circle. The point is actually this center here. And then I'm gonna define that there are 6 of those. Like that. Now I can exit this sketch, create an extrusion to cut, and then here I'm gonna select up to next, and then OK. Then Control 7, and that will be our finished part for this second tutorial. All right. Remember that this week we have the homework number 6. I'm gonna show it in a second. And also that you have to submit the first part for the final project. And that next week we're gonna have the third quiz, probably on Thursday. So on Tuesday we're gonna have just our class as usual. Remember, if you have questions, please connect to the office hours and we can discuss. Webex usually, if I am the only one in the room, Webex is gonna just close the room. But then just send me an email or write me in the WeChat. Sorry, in the GroupMe chat. That you want to meet with me, and then I can join the session again in Webex. The homework for this week, as usual, is gonna be due on Sunday at midnight. It's a very simple geometry, I think. Now that you're familiar with isometrics and hidden lines, please take into account those. How to interpret these planes that are like diagonal planes, and how to interpret all of these hidden lines, especially in the top view. Remember that you have to do the 3D body. From there I can track what you did in the other views. So don't bother on sending the 3 views, just the 3D body. It's enough. Of course, including the PDF file with the screenshots of your progress and the SolidWorks part file, as we have done with previous assignments. That's all for this class. Thank you for your attention, and see you next week. Remember that I have office hours on Tuesdays and Thursdays from 10 to 12:30. I hope to see you there. Bye bye.